All right. In this tutorial, we're going to use Autoshot to create a visual effects shot automatically. We already learned how to sync takes from a jet set to a Google Drive directory earlier, so now we'll start from there. Click Clear in the console window to clear the text out from previous runs. Under External Executables, I'm going to click Set, and we're going to browse to our previously installed Blender installation. Open, that sets the executable. And before we go into the rest of the setup, we should understand the process that Autoshot will use to make the shot. We're going to pick the source, temp, and output directories. Autoshot will list the shoot dates available in the source directory. We'll pick a shoot date, and then Autoshot will list out all the available takes in that shoot date. Once we pick a take, Autoshot will tell us which USDZ file was used in that take, and what scene locator or 3D mark was in use by JetSet when that take was shot. We can then pick which blend file we want Autoshot to link our shot to. Note that Autoshot won't modify our original blend file. It'll create a new blend file called a render or _RNDR blend file that is linked to the original Blender scene, but has the animated camera track and the compositing node network set up for us. We can override which scene locator or 3D mark we want Autoshot to use in the Blender scene and control some timeline parameters in and out points in the camera frame, and then we'll run the batch process and see a created blend file. So let's get started. Under folder setup, we have 3 folders to set. Source tells Autoshot where to look for our source takes. Temp is where Autoshot writes out our temporary files like image conversions, etc. And output is where Autoshot will write out the actual output directories with the image sequences, blend files, etc. that go into making the actual shot. We'll start with source. Source has 3 settings. JetSet link will pick the directory that is specified under the JetSet link area. See, shared drives like our Ben test captures. It's the directory that we just synced to in our earlier tutorial. And if you're about to process the same shots you just synced, great, you just use this and everything is ready. iCloud Desktop will point the folder toward your local iCloud Desktop installation for Windows if you have it. And finally, local folder lets you specify a given local folder on your PC. And in this case, we'll pick local folder as we're going to work from a different project folder that we already synchronized from JetSet. You'll see that Autoshot fills in the folder name from the last session this setting was used. And this is the correct folder name for our shoot. Note that all the directory entries, there's a button called Open. And Open just opens up a Windows Explorer build in the directory you're working at. That's it. Now we need to set up our temp directory. I set it on a local drive with a lot of space. Dtemp temp files is fine. And finally, we'll set our output directory. I have this on a shared folder mapped to F:/Flamenco in case we want to use Blender's Flamenco render farm system. I'll do a description of how to set that up in a later tutorial. Next are the values we'll set for our Autoshot run. AI Matte picks the AI matting engine that we'll use. Different AI matting engines can have considerably different results on a given piece of footage, so it's worth testing them. Engine picks the Blender render engine that the render file will be set to. Eevee is the current default, but keep an eye out for Eevee next, which should be amazing. Resolution is the output resolution that the render file will be set to. We'll leave it at default, which will retain the resolution of our camera original files. Day lets us pick the shooting day folder. If I click on this, you can see we had 2 separate iOS devices shooting on that day, and that each one of them made their own shooting day folder, which is under the top level JetSet Shoot 2023-121 folder. As I click these back and forth, you'll see that the take changes because there are different takes available. So we'll click NBNW P2023, as this was the main camera for the shoot, which was an iPhone 14 Pro shooting UHD 2160p footage. And when we select this, we'll see the take dropdown change. It might take a while to update as it works through all the takes in the shooting day folder. The take dropdown lets us pick which take of the shoot we want to use. We'll choose Scene 101, Take 17, as it has a good shot of our actor running toward us. When we pick this take, Autoshot automatically looks at the tracking JSON metadata file associated with this take and finds which USDZ model file was loaded into JetSet at the time of capture, and it writes that into the take USDZ. So we can see that it was NBNW13_ghost was the name of the USDZ file. We can now pick the scene blend file. We'll click Set and then navigate to the spot in our Blender subversion tree where our Blender scene is located. I'll pick NBNW16. And this is the Blender scene that we're going to reference when we create our new render file. Autoshot also found the scene locator or 3D mark that was in use at the time of shooting and writes it to the Take Scene Loc line. In this case, the scene locator was set to origin. Autoshot will automatically match the selected scene locator name in the USDZ take file with a matching scene locator name or 3D mark name in the blend file if it exists. And you can also use a specified scene locator or 3D mark name in the blend file with a Sceneloc override. You would write the override name of the scene locator that you want to use. And likewise, you can override the rotation of the tracking data, how it comes in, 0 degrees, 90 degrees, 180 degrees, 270 degrees. And that's a rotary offset. And that's quite useful in the not infrequent case where either the scene locator or the origin was misset and it's 90 degrees off. This is where you can override it without modifying the original Blender file. Timeline start frame picks the start frame of the original Blender timeline where the created composite will begin. So this defaults to 1, which is fine for stationary scenes. But for animated scenes, you will frequently want to start a composite at a given time frame. So for example, the plane starts coming at frame 130 in the Blender timeline, we're going to pick timeline start frame of 130. Likewise, camera start frame picks the first frame of the camera original footage that will be matched to the Blender timeline start frame that we just chose. So if our actor starts moving on frame 240 and we want that to correspond to frame 130 in the Blender animation scene, we would enter 130 in the timeline start frame and 240 in the camera start frame. Likewise, camera end frame picks the end of the shot that we want to process in the render file. We can enter 540 here, so the render file will be processing 300 frames. Camera start frame and end frame are the same as the in and out points in an editor. And at the point where Autoshot starts processing timelines, this will be automated. But until then, it's easy to enter the in and out points of a clip into Autoshot. Below this are the checkboxes for several batch processing switches that can be run during Autoshot. We'll go into more details on these in a later tutorial, but for now note that we have create Blender file, open Blender with render file, and add camera image plane checked. So it's going to create a Blender render file, it's going to open it, and it's going to add a camera image plane into that Blender render file. Pretty straightforward. All right, so go ahead and click Save and Run at the bottom. We'll see Autoshot extract still frames from the MP4 camera originals, and we're going to convert them over to DWAA compressed EXR frames in the CAM EXR directory. So we can see our progress over here. So it's going to create an Autoshot directory, and in that directory, it's going to create the tag name that we're processing, and it's going to create a CAM EXR. And here you see the individual EXR still frames being written out of the camera original frame. Next, we'll see Autoshot run the ModNet AI matting system and create a grayscale matte sequence in the AI mats directory. So over here, you can see our grayscale mats being created. And finally, we'll see Autoshot tell Blender to create a new render file in the blend directory that links to the original nbnw16.blend file as a background file, but adds the animated camera. All right, and then Blender will open up, and after the shaders compile, we can now see our working visual effects shot. Looks like we've got 2,500 shaders to go. Fantastic, here we go. So right now, our actor looks doubled, and that's because the viewport compositor size doesn't match the scene window size. The viewport compositor size is the whole window, and the actual rendering camera frame is this area. So let's go ahead and drag this up a little bit. You'll see them shrink till they match. Then you can scale the 3D viewport with the mouse wheel or Alt-Shift left mouse button until it roughly matches. And that's fine for the viewport compositor. We'll be doing precision compositing in the actual Blender compositor, but this is great for now. And set the bottom panel to timeline, which it's already at, and then run the timeline back and forth to see the shot animate. Great. So this is a good place to stop and save. And next we'll take a tour of Blender's new Viewport compositor and of the automatically created Autoshot node group that is doing the viewport keying.